People have been lying to you your entire life. You've probably heard myths about your body that you just assumed were true because an adult said so. However, we guarantee there are many things that you were told that aren't actually true. Does shaving your body make your hair grow faster? What really happens when you swallow your gum? Could you drink urine in extreme circumstances? Get ready to have your mind blown. Let's clear something up right off the bat. Most people believe that shaving your beard or any part of your body makes the hair grow back thicker and darker. But is there any truth to this? This belief likely came about over 100 years ago, but back in 1928 it was debunked. Yet almost everyone still believes this common body myth to be true. The fact of the matter is that when you shave, you aren't actually removing all of the hair from your skin. Instead, the hair is cut to its base, to where the follicle rests just under the skin. At this location, the hair is its thickest. After you shave, the hair starts to regrow from its base, which means it starts out coarser than when you initially sheared it off. This is what gives the impression that the hair is thicker than before. However, over time, the hairs will begin to taper off and become thinner with the wear and tear of everyday life. The color might also appear darker at first as the new hair growth has yet to be exposed to light, moisture, or chemicals and soap, all of which weakens the keratin that makes up your hair and causes it to become lighter and thinner. Given enough time, the hair will look identical to how it did before you shaved. Clinical trials and the data they've collected prove that hair does not grow back thicker or darker when you shave. Instead, this is just an illusion during the regrowth process. You still have the same amount of follicles, and the coloration will change back to what it was before you shaved, given enough time. What color is human blood? Depending on who you ask, you might get different answers. You probably know at least one person who thinks human blood is blue. Human blood is red. It is always red. It will always be red. The reason your blood is red is because it contains a molecule called hemoglobin. This is an incredibly important molecule because it allows your blood to carry oxygen around the body. Without hemoglobin, you would suffocate to death. Another property of hemoglobin is that it contains a lot of iron. It is this aspect of the molecule that makes your blood red. The reason your veins look blue is not that the blood flowing through them is blue, but because the veins absorb all the other wavelengths of light and only reflect back the color blue to your eyes. However, human blood is never blue. To be fair, your blood can be different shades of red depending on how much oxygen is in it. The more oxygen there is in blood, the brighter the red will be. If the oxygen levels are low, the blood will be a darker shade of red. Some creatures do have blue blood, but humans are not one of them. Octopi and horseshoe crabs both use a molecule called hemocyanin to transport oxygen in their blood. This molecule makes their blood blue. Incredibly, there are creatures such as the Prasinohama lizards that have green blood, so there's a variety of blood colors in the animal kingdom. But no matter what, all human blood is red. In practically every biology class around the world, students are taught that the ability to curl the tongue is an inherited trait. Unfortunately, you and everyone else who learned this fact has been lied to. In 1940, a geneticist named Alfred Sturtevant conducted an experiment where he gathered data on a group of children's abilities to roll their tongue and compared it to their parents. His conclusion was that parents who could roll their tongues had offspring with the same trait. This meant that the ability to roll your tongue is an inherited trait. For over a decade, this was thought to be the case. It became such common knowledge that a number of academic journals and textbooks even reference tongue curling when discussing genetics and inheritance. However, in 1952, a geneticist named Philip Matlock conducted his own experiment around the heritability of the rolling tongue trait. His findings were intriguing. Matlock studied used 33 sets of identical twins to see if tongue curling was in fact an inherited trait. Identical twins have the same exact DNA as one another. This is what makes them identical. If being able to curl your tongue is a trait passed on by a child's parents, then each set of twins should either have been able to roll their tongues or not. What Matlock found shattered a deeply held belief in the genetics community for over a decade. Out of the 33 sets of identical twins, 7 of them had one twin who could roll their tongue and one who could not. This clearly meant that being able to curl your tongue is not inherited from the DNA passed down by parents. Even to this day, though, biology teachers still teach the myth that the ability to curl your tongue is an inherited trait to entire classrooms full of students. But now you know better. It may seem insane, but even when professors try to correct this misconception, there is pushback from people. To combat this myth, some biology teachers start their genetics classes by conducting a survey of how many people can roll their tongues. The students who can't are told to go home and practice curling their tongues in front of the mirror to see if they can develop the skill. By the end of the semester, the number of students who can roll their tongues increases every year. And sticking with tongue myths, you've probably seen a diagram of the tongue that identifies each section as being able to sense specific tastes. Yet, this picture is a complete fabrication. The diagram itself came from a misrepresentation of the research done by a German scientist named David P. Hainig. Hainig claimed that differences in taste were a result of receptors in different parts of the mouth being activated by food molecules. Without Hainig's approval, the tongue diagram was made. Unfortunately, whoever created the image got it all wrong. Hainig never claimed that the different parts of the tongue contained neatly divided sections of taste buds. The truth is that all areas of the tongue and mouth contain taste buds, and they're all mixed together. There are unique receptor proteins responsible for identifying individual tastes, but they aren't clustered in neatly defined sections, and they definitely aren't all on the tongue. Therefore, the diagram that misrepresented Hainig's work is a complete fabrication, even though it is still sometimes used in anatomy and biology classes. Regardless of where taste receptors are located, drinking this next bodily fluid will taste horrible and will make you sick. Many people believe that you can drink urine in extreme circumstances because it is sterile. However, this is not true, and you should never drink your pee. Numerous studies have shown that people with no urinary tract infection still have bacteria in their urine. This means that urine is not sterile. In fact, multiple species of bacteria can live in the urine, which is not surprising as these organisms can practically survive anywhere. Medical professionals have noted that the bacteria in pee is probably not harmful if consumed, but they do not recommend it. Regardless, the myth that your pee is sterile is false, and under no circumstances should you drink straight urine. Like pee, there are a number of things you should probably not put into your body or swallow by accident. Luckily, gum isn't one of them. There's a myth that if you swallow gum, it'll stay in your body for several years. When you think about it, this would be absurd, as nothing stays in your body for that long except for your bones and organs. To be fair, gum is a pretty resilient substance and doesn't immediately burn up in stomach acid or break down from your digestive enzymes. Instead, your body has a different way of dealing with gum. When you swallow that chewy substance, it ends up in your stomach and eventually moves to your intestines. There are even reports of people having gum in their digestive tract for several days, but it's rare that it would stay there any longer than a week. So, what happens to the gum? You poop it out. Although the gum might not break down, it's still evacuated from your system with the rest of the waste in your digestive tract. Doctors have noted that if a kid swallows enough gum, it can cause constipation as it builds up in the intestines. However, with enough laxatives, this problem can be solved. Really, what it comes down to is you should try your best not to swallow gum in the first place, but if you do, there's no need to worry, as it'll eventually come out the other end after a few days. There's a lot of misconceptions about viruses and getting sick. At some point in your life, someone probably told you, "Bundle up or you'll catch a cold." What they're implying is that when you get too chilly, it can somehow make you sick. But is there any truth to this statement? If you were exposed to freezing temperatures for a prolonged period of time, it can definitely lead to hypothermia and malfunctioning of vital systems in your body. This would not just make you feel sick, but could lead to death. However, this is very different than catching a cold from a virus or bacteria. Because the common cold and the flu are both caused by viruses, the only way to catch them is by coming into contact with somebody who also has the virus. If you stood out in freezing cold with no one around you, it would be impossible to catch a cold caused by the pathogen. However, it does seem like people get sick more often during the colder seasons. So why is that? When a virus or bacteria enters your body, it normally gets caught in the mucus of your nose and throat. When you swallow, that mucus gets sent down your throat to your digestive system, where anything trapped in it is destroyed by the acids in your stomach. During cold weather, every time you breathe the cool air through your nose and mouth, the mucus also cools. This slows the slimy substance's movement through your body, which allows pathogens more time to break through the mucus barrier and get into your cells. Therefore, it's not the cold weather that made you sick, but a pathogen that's weaseled its way out of your mucous membrane and into the vulnerable parts of your body. It's not uncommon for someone to be afraid of flu shots or vaccines because they're nervous that they'll catch the virus from the vaccine itself. However, this myth is more of the result of coincidence and the misunderstanding of what a vaccine is more than anything else. A vaccine is made out of a completely dead or very weakened form of a pathogen. What this means is that it's impossible for the vaccine to give you the disease that it's designed to prevent because the parts of the pathogen that are in it are unable to replicate or infect your cells. For example, when you get the flu shot, parts of the flu are being injected into your body, but since they're inactive, there's no way the flu shot can give you the flu. So where does this myth come from and why is it so prevalent? There's no denying that sometimes after you get a vaccine you don't feel great, but this is to be expected. Your immune system is developing structures that will later fight off the real pathogen if it ever enters your body. The process might cause things like aches or a mild fever, because these are the natural side effects of your body boosting your immune system. However, people mistake the side effects for the flu itself. They then spread the rumor that the flu shot gave them the flu. Good thing is the side effects of a vaccine will always be much milder than getting sick from the disease itself. The myth also comes from a misunderstanding of correlation and causation. There's a chance you will get sick after a vaccine, but there's also a chance you'll get sick after watching a movie. Yet we don't assume watching the movie was the reason you got sick. Doing one of these things doesn't cause the other. And this is true with vaccines. You normally get vaccines at the doctor's office or in a hospital, and it should come as no surprise that there will likely be sick people at these locations that might be contagious. There's always a chance that when you go to get your vaccine, or even just a checkup, you'll come into contact with someone who is sick. In these circumstances, it's not the vaccine that made you ill, but being around a higher concentration of sick people. And since the vaccine only protects you against one type of pathogen, just because you got the flu shot does not mean you can't get the common cold while sitting in the waiting room at the doctor's office. So what it comes down to is that vaccines are safe, and they will absolutely protect you from the pathogen they've been designed to prevent. It is the people spreading misinformation about vaccines that are dangerous, not the vaccines themselves. Throughout history, people have reported that the hair and nails of recently deceased continues to grow. Is this gruesome rumor actually true? It does, in fact, appear that a corpse's fingernails and hair get longer even days after they've passed away. However, this is not because they continue to grow, but what actually happens due to an entirely different process. The myth dates back to 1929 when Eric Remarque wrote about it in his fictional novel, All Quiet on the Western Front. After the book became popular and was read by the masses, this belief became widespread. But like the book itself, this post-mortem myth was completely made up by the writer. It might seem like the nails and hair of a recently deceased cadaver grew longer even after they took their final breath, but this is actually just an illusion. What's really happening is that the skin around these regions is shrinking as water is lost. The dehydration process then causes the skin to retract and makes it seem as if the nails and hair are growing. This is a perfect example of why you can't believe everything you read unless it's from a credible source and supported by evidence. Your body is really good at getting rid of toxins. If it weren't, you'd be dead. But is there a better way to detox, such as drinking herbal remedies or cleansing your system with saltwater enemas? According to science, there are no treatments that can replace or improve upon the natural detox systems in your body. These structures include the kidneys, liver, and lungs. Your organs have evolved over millions of years to ensure that the blood circulating around your body has as few toxins in it as possible. Even as you watch this video, your body is hard at work taking out any harmful substances in your blood and breaking them down to make sure you excrete them before they poison you. There are tons of companies who try to sell the myth that there are miracle substances that can rid your body of toxins. Unless that person is a certified medical professional trying to get lethal amounts of drugs out of your system, they're lying to you. It's also interesting to note that any company that says their product will remove toxins from your body are often incredibly vague about which toxins they'll be targeting. The reason for this is because if they started naming specific molecules, their product could then be clinically tested, and the results probably wouldn't go in their favor. As a child, you might have been told to stop cracking your knuckles because it'll give you arthritis. There is some good news for those of us who do this when we're nervous. Cracking your knuckles has no connection to arthritis of any kind. Numerous studies have been done to debunk this claim. Scientists have concluded that there is no connection between habitual knuckle crackers and the development of arthritis. But there's another part of this myth that's also been debunked. According to the research, even people who already have arthritis can crack their knuckles, as this habit does not seem to make their arthritis any worse. There's also some downsides to cracking your knuckles, however. It seems that there is a correlation between knuckle cracking and reduction of grip strength. It's also possible to hurt yourself or dislocate a bone if you try too hard to get a knuckle to crack. The actual sound from cracking your knuckles comes from the popping of bubbles in your synovial fluid, which is the liquid that helps lubricate your joints. Sight, taste, smell, touch, and hearing. Those are the 5 human senses. Or are they? As we think of them, the 5 senses came from the ancient Greek philosopher Aristotle. He believed every sense could be connected back to a part of the body, and since Aristotle didn't know about the inner ear canal, or its importance in helping us maintain our sense of balance, along with many other structures, he left many of our senses off his list. Now we know that the vestibular system is responsible for helping us not fall over every time we take a step. Incredibly, your skin alone is capable of sensing several different stimuli. Your skin has receptors to identify not only touch, but pain, temperature, and proprioception. Proprioception, also known as kinesthesia, is your body's ability to sense movement and position. Now, depending on who you ask, you could have as many as 9 to 33 senses. Regardless of the exact number, humans definitely have more than just 5. Many people have been told that if they touch a frog, it can give them warts. This is just not possible, as the bumps on frogs aren't actually warts at all. This myth probably came from mothers who didn't want their children picking up dirty amphibians like frogs and toads. Truth of the matter is that the bumps on their skin are actually glands. You can never get warts from picking up one of these animals because warts come from something completely different than frogs. Warts are most often caused by a virus, such as the human papillomavirus, or HPV, which is the most common pathogen associated with warts. Therefore, unless a frog transfers a wart-causing virus to you, which is next to impossible since we are very different species, there's no way for a frog to give you warts. How much of the human brain actually gets used? You've probably heard that humans use only around 10% of their brain. Even this seems a little high for some people. However, this statistic isn't quite accurate, as it is a complete lie. The 10% myth might have been started by an American psychologist named William James, who wrote a book called The Energies of Men. In it, he said, "We are making use of only a small part of our possible mental and physical resources." James never threw out an exact percentage for brain use, but this could be where the 10% statistic started. Regardless of where it came from, you and every human on the planet uses 100% of their brain throughout the day. Even while you're asleep, your frontal cortex and somatosensory areas, which help you sense things around you, are still operating. These two sections already make up over 10% of your brain. Neuroscientists also point to the fact that your brain accounts for only around 3% of body weight, while it uses around 20% of your energy. This just shows you how active the organ is. There's no secret to unlocking more brain power because you are likely already using all of it already. Unfortunately, this means you probably don't have any latent superpowers, or the ability to talk to ghosts hidden away in a secret section of your nervous system. When was the last time you went swimming right after eating? Probably a very long time ago, because you believe the myth that you need to wait 30 minutes after eating to go swimming. The chances of drowning from a cramp are incredibly low. The chances of drowning from a cramp caused by eating before swimming are close to zero. Where this myth originated from is unclear, but it was mentioned in the book Scouting for Boys, which was published in 1908. The thought process behind it seems to have come from the idea that your body increases the amount of blood flowing to your stomach to help with digestion when you eat food. In theory, this can cause cramps, but it would be highly unlikely any digestion-caused cramp would be debilitating enough to cause you to drown. However, drinking 30 minutes before swimming can most certainly lead to death. We're not talking about drinking a soda or some lemonade. Instead, we're referring to alcohol, as intoxication is one of the leading causes of drowning around the world. Therefore, eating 30 minutes before swimming, probably okay. Getting in the water after a couple of margaritas or Mai Tais, different story. When it gets cold outside, you probably think about putting a hat on after your jacket. This is because a commonly held belief is that you lose more heat from your head than any other part of your body. This is not true. There are a couple of factors that cause people to hold on to this misconception. The first is that the head and face have a higher concentration of receptors that make them more sensitive to temperature changes in the environment. However, the body doesn't lose more heat from the head than other parts of the body. Some researchers have suggested that this myth originated from the United States military. In the 1950s, the US Army wanted to test survival gear in case the Cold War turned hot and they had to fight the Soviets in Arctic conditions. So they put soldiers in a freezing cold environment to ensure their outfits allowed them to retain enough body heat to operate in sub-zero temperatures. The snowsuits covered the body from neck to toe, but they did not cover their head. Therefore, the report noted that soldiers were losing most of their heat through their heads. But that was because it was the only part of the body that remained exposed. Somehow, the findings of this experiment got twisted into the soldiers losing more heat from their head than any other region of their body. But this would have been true about any part of their body that was directly exposed to cold temperatures of the Arctic. In practically every medical television show or movie you've ever seen where someone flatlines, the doctors rush in with a defibrillator and shock the patient back to life. But this is not how it works in the real world. Real medical professionals do not bring in a defibrillator when someone's heart stops beating. This is because it would do absolutely nothing. Defibrillators are used to shock a heart back to its normal rhythm if it's beating irregularly. The actual beating of the heart is caused by electrical signals coming from the brain and delivered through the nervous system. When these signals somehow get out of sync, it can lead to an irregular rhythm or heart attack. The defibrillator is then used to deliver an electric shock that forces the heart back to its normal rhythm. The key here is that the nervous system's electrical signals still need to be stimulating the heart for the defibrillator to work. If the heart has stopped beating completely and someone flatlines, it means there is no electrical signal to try to shock back into sync. Therefore, a defibrillator is useless in this situation. Luckily, real-world doctors know this and would never try to use a defibrillator in this type of situation. Instead, when a patient flatlines, medical professionals begin doing CPR to keep blood and oxygen flowing to the brain. As CPR is happening, the patient is given an epinephrine injection which increases adrenaline in the body and jump-starts the chemical signals in the brain. The ideal outcome is that the brain will then restart the heart and the blood will start pumping around the body again. One of your friends is sleepwalking around the house. You want to help, but you've been told if you wake them up, they could die. What do? First of all, don't panic. You will not kill your friend by waking them during a sleepwalking episode. Around 7% of people sleepwalk in their lifetime. However, no one has ever died from being awoken while sleepwalking. This myth came about before advances in neuroscience allowed us to better understand what's happening with the sleepwalker's brain. People used to think that when someone was sleepwalking, their soul left their body. It was thought that if you woke someone in this state, their soul would not be able to return to their body, and they would live the rest of their life as a soulless creature. We don't know the specific reasons that sleepwalking occurs, but it definitely isn't because someone's soul has left their body. Scientists have discovered that sleepwalking most often occurs when someone is in a deep stage of sleep and their brain starts signaling to their body to do certain activities while they're unconscious. The interesting thing is that sleepwalkers seem to be genetic, meaning that if one of your parents is a sleepwalker, you have a higher chance of sleepwalking yourself. When someone sleepwalks, their eyes are often open, but they do not respond to stimuli. Instead, they seem to be on autopilot, carrying out whatever task their brain is subconsciously signaling them to do. When encountering a sleepwalker, the best thing to do is just let them be until they wake up. You can gently guide them back to bed, as they will likely not realize you're even there, as you heard them in the right direction. It is absolutely okay to wake someone up if they're in danger while sleepwalking, but they might be disoriented and confused until they regain their bearings. There are actually accounts of sleepwalkers dying, but it's not because someone woke them up. Instead, there have been reports of sleepwalkers getting behind the wheel of a car and crashing, or cooking a meal on the stove and catching the house on fire. However, there's no evidence that simply waking a sleepwalker can kill them or cause them to lose their soul. You probably know someone who can bend their thumb all the way back to their wrist or contort their body in a crazy way. We call this being double-jointed, but in reality, there's no such thing. This body myth just comes from semantics. Everyone has the same number of joints, whether you're flexible or not. Being able to bend your body parts in unique ways does not mean that you can have more joints than someone who is less pliable. People who are more flexible can be identified as having hypermobility or joint laxity. This consists of somewhere between 10 to 25% of the human population. Rather than having extra joints, these people either have abnormally shaped bones or loose ligaments that allow them to move or stretch their bodies in unique ways. There isn't so much benefit to having hypermobility other than to impress your friends with it or go into a line of work where contorting your body is advantageous, like dancing. But regardless of how flexible you are, you still have that same number of joints as everyone else. There are a lot of weight loss techniques that companies try to sell that are unsubstantiated by science. There are also some diets and lifestyles that can help you lose weight, but which ones are true and which ones are just phony baloney? Many diet regimens call for low-carb intake. This can definitely lead to weight loss, but it can also be taken too far. Carbohydrates are a form of stored energy that your body needs. Like anything, as long as high-carb foods are eaten in moderation, it's okay to have them now and then. There actually isn't much you can't eat and still lose weight as long as you monitor your intake. Diets that claim that all carbs are bad and therefore you shouldn't be eating whole grains or fruits have no scientific basis. You need carbs, and your body definitely needs the other vitamins and nutrients found in those types of foods. That being said, highly processed foods high in carbohydrates like chips and cookies can definitely be taken out of a diet to aid in weight loss. But that's just not because they contain carbs, they also have high amounts of saturated fats and sodium as well. So any diets that claim you can't eat carbs at all is definitely not healthy and should be avoided. If you reduce the amount of processed foods you eat and exercise regularly, you'll have greater success losing weight than any miracle diet. There are some foods that people swear have miraculous effects on the body. However, sometimes this is taken too far. You might have been tricked into eating carrots with claims that this magical vegetable will give you night vision. Unfortunately, this is far from the truth. Researchers have shown that carrots are definitely good for your eyesight, but they will never allow you to see in a pitch-black environment. It's believed this myth came out of World War II as a way to trick the enemy. False information was being fed to Axis powers that carrots Allied soldiers were eating gave them night vision. It was because of the orange vegetable that Allied forces were so successful at shooting down enemy aircraft at night. This was just a clever lie to disguise the fact that the Allies had developed a radar system that allowed them to target Axis forces more accurately. The carrots that the Allies were eating at the time had very little effect on their eyesight of the pilots and the soldiers. However, there are definitely benefits to eating carrots. They are a good source of vitamin A, which enables your eyes to convert light into readable signals by the brain. This does, in theory, increase someone's ability to see in low-light environments, but it's nowhere near enough to give them night vision. There is a catch to the miracle of carrots, though. In order for the vitamins contained within the vegetable to be absorbed into your cells, the carrots need to be consumed with fat. This means that if you're just munching on carrots, they'll have very little benefit to your eyesight. However, if you pair them with a nice piece of meat, it'll allow for more vitamin A to reach your optic nerves. An easier method for obtaining vitamin A for improved eyesight is by taking a multivitamin or a vitamin A supplement. This has been shown to be much more effective than eating mass quantities of carrots on a daily basis. Another common misconception is that turkey makes you sleepy because it contains an amino acid called tryptophan. You have likely felt sleepy after eating a Thanksgiving meal, and someone told you the reason for this is because the turkey contains tryptophan. They're not wrong in that turkey contains tryptophan, and that molecule does in fact make you drowsy. However, it's not the reason you're tired after a Thanksgiving meal. There's the same amount of tryptophan in almost all meats as there is in turkey. Even foods like soybeans, cheese, and some seeds contain the same levels of tryptophan as turkey does. However, like in all these foods, the amount of tryptophan in turkey is significantly less than most other amino acids. Even though a small amount of tryptophan circulates around your body after you eat turkey, it has to compete with at least 5 other more abundant amino acids to gain access to your brain. This reduces its impact even further. What it comes down to is that after a large Thanksgiving meal, your body needs to use a lot of energy to break down the starches, fats, carbohydrates that you just consumed. And it's not the tryptophan that's making you sleepy, it's the digestive process. So it doesn't really matter if you eat turkey or not, you'll still get pretty sleepy after any large meal. There's a common thought among the workout community that if you don't continue weightlifting, your muscles will turn to fat. You might be surprised to learn that muscles and fat are 2 completely different types of tissue, and one can never turn into the other. Although it is true that if you stop working out and lifting weights, your muscles will shrink, they definitely will not turn into fat. Yet there seems to be a connection between stopping a workout regimen and the development of fat on the body. Health experts explain that it's not the muscles turning into fat that causes the increase in body fat, but the change in lifestyle in general. What happens is that working out is often connected to trying to live a healthier, more active lifestyle. When a gym routine falls to the wayside, oftentimes other aspects of staying healthy do as well. It's a combination of less exercise, worse eating habits, and the slowing down of someone's metabolism due to inactivity that makes it seem like their muscles are turning into fat. Theoretically, someone could stop lifting weights and still maintain a healthy and active lifestyle, which would result in no new fat accumulation, but even still their muscles would start to reduce in size. Coffee is the go-to beverage for someone trying to wake up in the morning. However, it's often said children shouldn't drink coffee because it could stunt their growth. There are definitely reasons that a young person should stay away from coffee, but stunted growth, not one of them. There have been a number of studies done on this myth, and they've found no evidence that connects coffee to impaired growth. The myth most likely comes from the idea that the caffeine in coffee can cause osteoporosis or a deficiency in vitamin D. This can impact bone density and make them more fragile. However, the amount of caffeine contained in coffee has very little effect on the strength of bones. This small effect can easily be offset by drinking milk or consuming other forms of calcium. Researchers warn that even though coffee won't stunt a child's growth, it could cause other problems such as high blood pressure, but this is true for anyone who puts caffeine into their body. For this reason, it's best for everyone to limit the amount of caffeine they consume, not just children. Also, caffeine is an addictive substance, which can cause withdrawal symptoms if levels in the body are too low. These symptoms can be exacerbated by the fact that a child's brain is still developing. Therefore, it's better to keep kids away from coffee until they're more mature. However, at no point will drinking coffee impact growth. And speaking of addiction, there's a myth that getting addicted to something is a choice. Yet scientists, researchers, and medical professionals have been trying to change this misconception for decades. The body is extremely complex, but there is one organ in particular that we still have just scratched the surface of understanding. The brain controls everything in the body and is responsible for our addictive tendencies. Unfortunately, when it encounters a substance with the right chemical properties, the brain can be reprogrammed to crave that substance. A lot of pain-relieving medication can be addictive because of the lack of pain is a feeling that the brain enjoys. Other addictive substances like drugs, alcohol, or even caffeine cause the brain to release dopamine and other chemicals that make you feel happy. Your brain then wants to be in that state of pleasure more and more frequently, which eventually can lead to addiction. However, scientists have discovered that oftentimes it's not necessarily the drug that's addictive, but some people are more addictable than others. This can be because of a genetic predisposition or caused by an event during a person's lifetime. What it comes down to is that addiction is the result of how our brains are wired. And since no one can control that, there's no way addiction can be the fault of an individual. That's why it's important to debunk the myth that addiction is a choice and educate others so that everyone can get the help they need. Now watch common myths that are still believed to be facts, or check out terrifying urban legends that turned out to be real.